Last week we looked at response time elements, the components that make up the overall response time of a service. So we saw that there is a request spread, so the actual request for a service may be spread across a number of packets. Then we have a service time, and then there may be a spread of response packets. And what I'm going to do today is look at a trace of accessing a file off of a file server, and we're going to look at these different elements of spread and service time and overall response time. So this is the configuration. We have a Windows PC that's accessing a file server across the internet. So we have a VPN that terminates on a firewall, and via that VPN we're gaining access to a file server that's listening on TCP port 445. And we try to open a PDF in Adobe Acrobat Reader, Network Trace Analysis Strategies whitepaper.pdf. And this takes about 30 seconds to open. And what we've done is we've traced the network activity during this time using dumpcap running on the file server. So what I'm going to do is have a look at that trace file. So let's start by looking for a string value in the packet list area of .pdf, just to check that we've actually got the entries in here. And here you can clearly see an attempt to open this particular PDF. In SMB you do an open with a create command. You just set a special value called disposition to open if exists. So we don't actually create a new file, we're simply opening an existing one. So that all looks good, and I'm going to now look at the response to that packet, or to that SMB message, and let's expand out the SMB header a bit. And what I'm interested in initially is this value here. This actually gives us the response time value. So Wireshark is measuring from the first request packet to the last response packet, and it's giving us an overall response time. And we'll see this is different to the actual service time. So let's actually add that in as a column. And I'm also going to add another column, which is delta from the previously displayed frame, just to give us an idea of delta values. Just quickly edit the details here. Let's call that delta. And I'm going to actually move that to the other side. Right, so now we're ready. So the next thing I'm going to do is I'm going to look for some slow response times. So if I prepare a filter to select SMB time value of greater than 1 second, and here we see some examples. Well, I'm going to choose this one here. So you can see that we've got a response time of 1.29 seconds. So let's follow that stream. So that just makes sure that we're looking at the right TCP connection. And I'm also going to make sure that we are only looking at packets which actually have TCP payload. Oops, greater than 0. So that eliminates all the standalone ACKs and all those types of things. Now this is a response, and it says 1.29 seconds, and if we look a bit further down here we can see that it's a response to a request at 389. So let's go to 389, and here we clearly see the request, and we can double check these actually, because if you look at this command sequence number, This is an SMB unique identifier for a particular command on this SMB session. So it's 701, and if we go back to our response, we see that the command sequence number is 701. So that gives us the request and the response. Now what I'm interested in is that if we look here, this response is made up of 27 reassembled packets, the first one being packet number 390. So let's go to 390, which of course is immediately after the actual request that caused all of this, which is at 389. And now we can look at the difference between the request packet arriving at the server, remembering that we're tracing this at the server, and the response, the first response packet. And you can clearly see that the time difference between these two is around 1 millisecond. In fact, you can see the value here, which is 947 microseconds. Of course, that's vastly different from the actual value that we see in the response. So we've got around 1 millisecond of service time versus 1.297 seconds of overall response time. So here we can clearly see the difference between service time and response time. So if we go back to this information here, what we're looking at is the service time from here to here, about 1 millisecond, and then the overall response time, which includes the spread of all these response packets, the 27 response packets that make up the response. So if I was looking at a problem and I saw this and I wanted to try and determine why I had a response time issue, I wouldn't be focusing on the server because the service time is quite fast. I'd be focused more on what's causing the long response spread. I hope that helps, and I'll see you next time.